Hello, I'm Jim Webb, and I'm going to be talking to you about the highlights of Chapter 6 for my ITSC 1325 class. Now, motherboards, that's where everything comes together. They've come a long way. They're going to go further, but let's get started. We're going to look at how motherboards work, what a modern expansion bus looks like and does, and how to install and upgrade motherboards. We do this prior to going into lab for a reason. Also, we'll look at how to troubleshoot them. The motherboards are basically the foundation for the personal computer. They have all the wires that connect the devices. They're called traces. Those are usually embedded in the motherboard themselves, which are made up of PCBs, extremely thin, and there's thousands of them. Without the motherboard, we would not have a PC. Now, the form factor determines the size of the motherboard, where things are located. The chipset determines where you're going to get your processor and RAM and what types they are. And the built-in components determine what your motherboard will allow your computer to do. Some of the things that the form factor has is size and shape, the power supply, and also how air moves around the case. Now, you guys weren't there for it, but I was there when they spec'd laminar airflow, oh gosh, close to 40 years ago, and it was a screaming match. They'll also find out about upgrades, recommendations, etc. Now, IBM invented the AT form factor in the early 1990s. Now, take a look at this sucker. It was a big puppy. A lot of chips, a lot of sockets, and it had one external connection. It was the keyboard. I'm sorry, two. The other was the monitor. So you couldn't do a lot with these except type. It was more like a traditional computer. As time went on, we added additional things. Now, the AT was a smaller version of the old one, okay? And let's see, there's your connector just for the keyboard. Then the ATX came along, 1995. Think what's going on. Ooh, Office 95, etc. It had a lot more ports at the rear of the PC. It also had this minied in for the keyboard. The CPU and RAM were placed closer together, easier to access, and the RAM was closer to the North Bridge and the CPU for better performance. Even though the electrons are going back and forth at the speed of light, if they're going 6 inches, a billion times a second, you need them to be closer. It will make it faster. There we go. Now here's a look at an early ATX motherboard. On the far left-hand side, we see the PCI slots. Then we're seeing the AGP slot. Now, prior to that, every video card would go in a PCI slot, which were kind of slow. The AGP allowed us to have fairly rapid connections. Here, you see that they have the RAM in banks. Okay, let's see, CPU, external ports. Usually it was a for a printer. Of course, here is your keyboard. The mouse was about to come on the scene big time. Here we have our BIOS chip. We talked about that earlier. System clock front panel connectors, such as the on-off button. Dip switches, we don't see those anymore. The South Bridge and the North Bridge chips. Notice the South Bridge not so big, North Bridge big. That's because most of the important things were on the North Bridge at that time. EIDE ports and power connections. Ooh, look how few pins there are there. Going forward, in the back, they started color coding the form factor. So I've got my keyboard, I've got my mouse, I've got my RS-232, I've got my DVI, I have my VGA, I have my USB slots, I've got a FireWire, I've got my Ethernet cable, RJ45, and I've got sound connectors. Now look at the two of these compared side by side. This thing's huge, bulky, doesn't do much. Faster, and it has a heck of a lot more sockets that you can plug external devices into, and more of those will be coming up. Notice how it's all color coded. Makes it a lot easier to understand and work with. The micro ATX, smaller than the ATX by 30%. Incidentally, I built tons of these. It allows you to put them in smaller boxes, and they don't take up nearly as much space. They fit well on your desktop. Okay, the Flex ATX, smallest motherboard, it's not used much anymore. The ITX, okay, was a small form factor motherboard. Didn't last long, but they still have several sizes out there. Mini ITX was the largest and most popular, 6.7 by 6.7 inches, and it competed directly with the Micro ATX. Now, proprietary form factors. That's when a company makes their own motherboard. Can you say no upgrading, no repair? They don't follow standards. And there are reasons for that. Commercially, they might have specialty parts, but again, if something goes wrong, hard to find parts for it. The chipset determines the processor type and the type and capacity of RAM. For instance, unless it's a 32-bit system, you're stuck with older 16-bit technology. The newer ones are 64-bit. You want to have a 64-bit processor. You want to have the RAM that's appropriate to that. Okay, and it serves as the interface through which the CPU, RAM, and the I/O devices interact. Originally, there were two chips, Northbridge and Southbridge. Northbridge did video and memory operations. Southbridge did everything else. Okay, Northbridge, yeah, CPU and RAM, communications. Southbridge, expansion devices, and originally mass storage went here. And we'll talk about that later. And a Super I/O chip, which would help you with older devices. Okay, here's old Super I/O. Now here's a fairly modern one. And if you take a look at this, pretty interesting. Here, let's see, we got the 8th generation chip, and then we have all these peripherals and gadgets on the board. Here, let's see, the chipset, etc. So it does a lot more. There's a lot more parts to it. It's highly integrated and allows us to do more with less, faster, more accurately, which is kind of the bellwether of this. Not all chipsets may be supported with ports. For instance, some of these do not have an IEEE or a FireWire. Some of them have more or less USB ports. Some of them have built-in sound, built-in networking, built-in video. Some don't. And some of them have built-in RAID, which we'll have a long discussion about, redundant array of independent disks. Okay, here we go. Here's some more connectors. Oh, and look at this, some colors. Can we say USB 3.0 and 3.1? And then, ooh, looks like maybe a FireWire. Then the case fan. Now, case fan, you need to blow air over the processor. So you're going to need that, and you're going to need the case itself. The chips are moving like a bat out of heck. So when you put electricity through silicon, it puts off heat. You want to get the heat out of the motherboard. Okay, let's see. Usually there's a 3 or 4 pin connector for the case fan. The microprocessor fan usually has 3 or 4 wires, and you make sure they're plugged in. You can add more, and they can be various sizes. You can have them flashing colors, etc. The larger ones tend to be quieter and move more air. Now, the expansion bus. Originally, IBM had slots built into the motherboard, and it would add new functions to the PC. The slots and the wires, let's see, on the latest PCs, they're called the expansion bus, yada, yada, yada. And every device in the computer connects to the external data bus and the address bus. It applies whether it's soldered in, whether it's in through a socket, okay? And the expansion slots connect the rest of the PC through the chipset. So the chipset provides an extension of the address data bus. Okay, so what all this is telling me is everything's connected through the wires, the sockets, etc. Everything connects at some point to the CPU or has an avenue to it. There we go. For instance, we have sockets, the chipset, CPU, okay, self-explanatory. And then some of these sockets, connect directly to the CPU. The newer video cards, the PCIe 16X connect directly to the CPU, gives it the fastest speed, and that's important for your RAM, and it's important for your video. Also, the chipsets connect directly into it. Now, the crystal clock controls the CPU and the speeds, okay? The expansion slots run at a slower speed, okay, than the front side bus. So the expansion bus crystal, controlled by the external data bus, is connected to the expansion bus. So what these clocks are doing is make sure that everything works together in terms of clock cycles. Otherwise, you get what's called a race condition, and different parts of the computer motherboard are operating at different speeds. Then, here's some diagrams of the same thing. So expansion crystal, here's my sockets. Here it goes in the chipset, here it goes directly to the CPU, and here's the system crystal. So lots of expansion crystals. And again, it's a matter of timing, just like dancing. Now, Intel in the 1990s introduced the PCI. Actually, before that, there was something called AGP. It was ISA, industry standard architecture, big, bulky, less pins, they were thicker. 1990s, when Intel introduced this, thinner, more pins, faster, okay? PCI was a wider, faster, more flexible alternative. Original bus was 32 bits wide and ran at 33 megahertz. It could coexist with other expansion buses. Early motherboards would have both PCI and ISA together. The PCI devices are self-configuring, and this led to the plug and play, which I really like. So instead of having to write a lot of code, I simply plug it in. I may have to install a little bit of software off a disk, but it works first time, every time. Also, they had a burst mode for very high-speed transfers. There we go. Now, a mini PCI, okay, designed for low power, lie flat, and where would we use that? Oh, with things that have to be in automotive controllers, portable gadgets, etc. Now, the PCI Express, PCIe, fastest, latest, most popular. It's still a PCI, uses point-to-point serial communications instead of sharing parallel communications, and it doesn't share the bus. Every PCI device has its own direct connection to the CPU. That's why the video cards connect directly to it. It has no overhead issues with data order, checking bits, etc. PCI uses one wire for sending and one for receiving. And theoretically, you could send 256 giga transfers per second through. What will we ever do with that, Mr. Webb? Well, we'll find 3D computing that will need it, or virtual reality. And the transfer rate describes number of operations handling per second, yada, yada. Now, the most common PCIe is the 16-lane version used for video cards. Installing these expansion cards, pretty simple. Basically, is it going to work with my system? Does it have the drivers? Yeah, I don't get stuff at garage sales or from strange companies in China that aren't well documented. I make sure that it works. Then physical installation, turn the computer off, put a ground strap on, open the case, plug it in, and then add your drivers. Pretty simple. Here we go. Don't touch the top. Only touch the edges. Here we go. Put a screw in so it doesn't flop around. Try to make sure they're not too close to each other. It's not such of a problem nowadays, but it used to be. And then the drivers. Always check to make sure you got the most recent drivers. If you've got an older card, it may be a problem. You can always download the newer ones. There we go. Read the README files. Now, uninstalling device. Some people just go to the folder and delete it. Don't do that. It may have shared resources. If you delete it, it may delete resources that you're not aware of. Let's see. It's nice if it is a signed driver, meaning Microsoft has tested it. It's gone through their program. It doesn't shake, rattle, or roll and work improperly. The problem is Microsoft doesn't like competitors, and they're a little bit slow on making sure that their parts are signed. Now, installing a new driver, it can either be done through Windows. It can detect and do it automatically. You can do through the internet, or you can use a disk. You can also roll back a driver after installation if it's not working properly. There we go. On verification, once you change everything, make sure it works. If it doesn't, might want to install the driver and reinstall it just in case something happened. Also, during the installation of new devices is usually when most of the mischief occurs with your BIOS. Okay. Look at this. Properly installed cards rarely cause trouble. Okay. A botched installation will. That's why you want to make sure you're grounded. Okay. And then the device manager. It's a diagnostic tool that will let you know if something's physically damaged, if there's a problem with the driver, etc. Look at the error codes. Black with the exclamation says there's a device is missing. Ooh. It may work even though it has an error. Black with downward pointing arrow indicates a disabled device. Sometimes during installation the thing can get tripped. There you go. With an exclamation mark, could be a problem. Now, double check the connections. Try reinstalling it. Okay, physically reinstall the drivers. If that doesn't work, something's not right. Make sure you've got the latest drivers. Plus, you may have to update them over time. Things change. Now, how do you choose a motherboard and case? I'm always buying a motherboard that will give me just enough to do the job that I need. I can upgrade the CPU. I can increase the RAM later. I don't need to get the fastest one around. I make sure that the form factor will fit in the case that I'm going to use, or if I'm buying a case, that they're compatible. Okay? Make sure you have enough power. Now, it depends on what you're doing. If you're just doing home stuff, 550, 600 watts should do good. If you're a gamer, that's not going to be enough. Then when installing a motherboard, make sure all the cards are removed. Remove obstructing drives. Remove the power supply. Unscrew the old motherboard. Plug the stuff in the new motherboard and reinstall. Okay. Also, standouts. You need to make sure that the motherboard is not physically touching the case. Can cause a short. You'll have to connect LEDs, all these front panel things. Okay, make sure all your fans are correctly installed, that you put the appropriate wires where they need to go, connect the power, and test the system. Now this is a standoff. What you're looking at is if you place the motherboard over that, there's a through hole. Put a screw in that without stripping it, and that keeps it away from the case itself. That way you don't ground it accidentally. Test the power to make sure it works. If you have a postcard, nobody does, connect it. Okay. Now, if there's no power at all, check the connectors to the motherboard. If there's power for the motherboard and fans, but nothing on the screen, check your RAM. That's a big one. If you bumped it and it's loose, that's bad. The same thing with the video card. Go. And incidentally, those front panel wires are a booger bear. Sometimes it's easier to connect those, even though it makes it a little bit more difficult to put the motherboard in. Once they're in the case, it's going to be dark. And the new thing is everybody's got black connectors, a black substrate. Really needs some good stuff. Now, troubleshootings. Most electronic components are going to fail when you install them. If they don't, the chances of them working for a long time are pretty good. So you have three types of failures that they go into here: catastrophic, component, and ethereal. Catastrophic, it won't boot, it won't work, could have had ESD shock, could have done something bad. Others, components. Now, MTBF, if you have a component and you're installing it, it has already been burned in by the factory. They know it works, and if it does not work, it's pretty rare these days. So if it's a bad component or bad driver, etc., okay, it can also be a problem with the power. Other times it just doesn't work right. Blue screen of death. That's where you get paid the big bucks for solving it. Okay. Now, techniques. Isolate a problem by eliminating potential factors. I have a lot of replacement parts. For instance, if a hard drive's not working, I've got cables, I've got alternate hard drives, I've got RAM, I've got power supplies. I can trade them out to make sure that everything's working. Other things, let's see, replace the motherboard, etc. Again, you're swapping out parts.